Our next speaker is Josema Cavanillas, Global Head of HCI Technology Consulting at Atos, Global Business Development Executive for Life Sciences and member of the scientific community. Josema brings a wealth of expertise in sales and business development across a wide range of countries in his global role, and has acted in sales and delivery on all continents, from Latin America to China, from Indonesia to USA. Josema, the stage is yours.
Thank you very much.
Thank you. Mm-hmm.
Thank you very much. That's much better. Okay. So thank you for coming. Let's speak about hospital networks. Hope it works. No? Yes, it does. Okay. When I speak about hospital network, there are two concepts of that. A hospital network is a group of hospitals working together. That's one concept, and actually very common. But today, when I speak about hospital network, I mean the IT network of a hospital. That is today a hospital network concept. And actually what we do is to understand how the computers or the different devices of the hospital link together and talk, and how they should do it better and to avoid threats. And we do it by using a sort of doctor with a sort of a stethoscope that from a passive way understands the network, perceives what is happening in the network, and actually concludes some results that can be helpful for the hospital. So we are somehow a doctor of the network. Let's have a look at the patient. What are the hospital networks? How do hospital networks work? IT networks. So first of all, from a physical point of view, we use wired and wireless connections. In a hospital, you have a very broad LAN, a very broad wide network, usually optical fiber, but also other kind of cables, and also a Wi-Fi, and also doctors and other professionals connecting from outside the hospital to the hospital for doing remote work or remote monitoring or whatever. So from a physical point of view, it has some complications, but from a topological point of view, there are several structures. The initial structure is a star topology. That's when every single hospital started to make a network, they usually start with a star topology, but it has some problems. The problem is basically scalability. As soon as the amount of devices becomes very big, there is a hub in which the connection becomes some complicated. So other structures, other topologies like ring or bus are pursued, in which you don't have the hub, but you share the communication channel. And then, let's say the tricky point is the communication channel that is shared. Then also you can play with the tree topology. Tree topology is actually a collection of stars, that's what it is, connected through a bus. It helps because many communications do not have to go through a common communication channel, but actually the best one and the most expensive one is the mesh topology, in which everybody is connected to everybody. This is really expensive to undertake. When we have come to our customers, which are usually hospitals, the most common topology is a hybrid topology. Actually, it's a juxtaposition of different networks and subnetworks that connect in a way, and it is the most common. Why? Because every single department has their own network, and their own network, which they decided to have a topology, then they connect to the rest, and then you even have some networks which are isolated, but they are not that isolated because at the end they connect to the rest of the networks. And what we find usually is a juxtaposition of different topologies. That is the most usual case. Okay, and then what do hospitals connect to the network? Let's go. First of all, of course, they have to connect high-precision image devices, and high-precision devices in general, which produce a lot of data and have to be conveyed through the network. But also other measurement devices, which are not necessarily high-precision, with a lower amount of data. Sometimes they are directly connected, sometimes they are collecting data and then plugged, and then downloading the data they have charged. Of course, storage devices, big and small storage devices, and also printers of all kinds, even specific printers for medicine, computers, laptops, and also the tablets used by the nurses in everyday's work, and things like environmental sensors, that's it, which you need to have for controlling the hospital, but also things as stupid as a closed-circuit camera, which is also used in the hospital and is also used in some of the subnetworks used there. This is more important than you think. I will come back later to this. Anything at the end of the day is connected to the network. Let's have a look now at the patient. We have many, many patients, many, many hospitals to be addressed. In Europe, there are 24,260 hospitals. That's the data of this year by Statista, out of which 9,000 are in Eastern Europe. Actually, 1.2 thousand in Poland, just to mention the biggest one in the Eastern Europe. In Serbia, where we are, there are 350 of different sizes and categories. And actually, the segmentation of hospitals is done based on the bed size. So below 100 beds is considered to be small, between 100 and 500 are considered to be medium, and large is considered to be above 500 beds. The very, very large hospitals, which is above 1.5 thousand, are usually university hospitals. But beds is just a parameter. Actually, it's not the right parameter. When you go to internet, everybody is measuring hospitals in bed, but it's not true. If you go to a hospital with 8 beds, which is a high specialization center with 7 different labs, there's a huge complexity in the IT network, even if it's a small hospital. Why? Because bed is not the right parameter to determine the complexity of the network you are addressing. Just to complete the information, there are only 21 hospitals in Europe which are above 1.5 thousand. These are the 6 biggest ones. Funny as it may seem, the biggest is here in Belgrade, but the other 5 are in other parts of Europe. If there's some French here, will tell me that Hôpitaux de Paris is bigger and they have 20,000 beds. No, Hôpitaux de Paris is a conglomeration of hospitals. The biggest hospital in Hôpitaux de Paris is 1.6 thousand, and it's in 21. Okay, so now this is hospitals today. Where are hospitals going to? The main trends today in hospitals are 2. The first trend is the reduction in the number of hospitals. If you go year after year, the amount of hospitals is going down because they are closing or revamping all hospitals, which are 30, 40, even 50-year-old. And they are optimization of rural areas. So basically in rural areas, instead of having 3 hospitals, they are coming to 1 because they are enabling new transport means and they are covering the same rural area with only 1 hospital, thanks to putting basically heliports in every village. That's happening in southern Spain for sure, but also in many other parts of Europe. The second trend is the size. We are reducing the size of the average size of the hospital. Why? Because we are working towards personalized care. And personalized care means you need less patients to be taken care of with a higher intensity in each one. Of course, managing a large hospital is much more complicated than a small hospital, so from a management point of view, it's better to have small hospitals. So they are abandoning the model of the mega hospital, for sure. And the new hospitals which are built are small and high-tech. You can read the directives of NHS for new hospitals. Actually, you can read a lot about that, and Atos was collaborating with NHS on that strategy. And now the new hospitals, many of them are just specialized. So it's only oncology, but only this kind of oncology. There is a hospital only for the knee, actually, which is built specifically for that. And that is true, hospital grouping is promoted. So now IT network is not only your network, but your network plus the network of the other hospital, how they connect, and the threats are shared. So more work for us. Who are working on the hospital network? Usually, in a large hospital, you have a large IT department. But remember, only 21 hospitals in Europe are large. 1 out of 1,000. Most hospitals in Europe are small hospitals. Thousands and thousands of hospitals. My Polish colleague told me 900 in Poland are really small, and they have only 1 person, the IT guy. The IT guy is himself the IT department. Sometimes it's 3 people, sometimes it's 10, but most times it's 1. And this guy is a guy living in the locality, living in the village, which is responsible for network continuity, so new device includes in the network, and he is responsible for it works and the network doesn't break. Doing the backup, of course, we have to do backup of the data. Put the toner in the printer, the same guy. Working on the purposes workplace, so it means every single doctor, every single nurse in the laptop should have the same software. If somebody introduces a new kind of software, that breaks the thing, that breaks the streamlining, then actually is a risk. So he's taking care of everybody has the same workplace. But also new hospital applications. As Lydia has said, many hospital applications are not specially happy or prepared to share with other applications. So he really has to take care that every application works and doesn't break or doesn't walk on the toes of the other applications running on the same network. The same guy is responsible for the antivirus. and protect everything. If there is a problem, he's the one called up. And actually, that's a little bit of a mess, because security means that if it's Saturday, 2 a.m., and you're peacefully sleeping, somebody calls you and say, hey, there is a ransom attack in the hospital. You have to wake up and come. Why me? Because you are the only one, and you have to come. And actually, there are 1,000 risks in the world, and this guy does not know the 1,000. Maybe he knows, maybe he doesn't know, but for sure he has lost the weekend, and maybe unsuccessfully, because on Monday it's still not solved. So this jack of all trades, I'm really sorry for him, and it's so common in Europe to have this kind of professionals. Also, if there's a bad guy, you're saying, come on, let's make something innovative. Let's connect to cloud. I don't know about cloud, okay? Get a certificate. When? I don't have the time. Yeah, get the certificate in Amazon, in Microsoft, whatever, because we need to go to cloud. And as I mentioned before, solving crisis in an emergency mode. Saturday, 2 a.m. So who are we? Who am I? I haven't mentioned that yet. We are Atos. We are a business leading in managed services. We work in technological services with decarbonized, automated, and AI-enabled solutions. We are 49,000 people in working on 69 countries in Advanced What Matters. We're passionate experts, world-class partners. We aim to have a meaningful impact, and our motto is the power of we, the power of the team that we are. In summary, we have 1.2 thousand customers. We are a global leader in infrastructures. We are in 69 countries. We have been more than 25 years. Our revenue last year was 5.4 billion euros, 49,000 people, and me, I am the head of the technological consulting part of hybrid cloud and infrastructure such as network. Okay, how do we support hospital network? We do 3 service lines. The first one is network advisory. So we see the network, we look at the network, and we tell you, these are the things you should improve in your network. Consulting. Second, we implement things upon demand. Hey guy, I cannot implement this software. I cannot do it. Okay, don't worry, we will do it for you. And the third thing we do is managed services. Don't worry, we take care of everything. We take care of the network, we take care of the cloud, we take care of everything. So you can't forget. We sit down by this jack of all trades and say, we are your partner, we're going to support you, don't worry. We take care of business continuity of the network. If you insert a new thing, we connect to cloud if you need to connect to cloud. We install and customize new hospital software. We take care of all the backups. By the way, the Polish government sent some weeks ago a regulation saying that every single hospital needed to have 3 backup lines, local, remote, and cloud-based, because they have seen an increased amount of attacks coming in hospitals, and there was a need for implementing these backups. And there are 900 jack of all trades saying, come on, what can I do? We take care about workplace, streamlining what everybody's doing. We take care about security. We have experts on that, and we can definitely help hospital in that. But let me go to the network advisory, the entry point. We have a passive network. We insert in the network a passive device. This passive device is based or is connected on the back part to our cloud with an AI software that listens to the metadata. We work on metadata. We don't look at data. Data is private. Data belongs to the hospital. We can learn about the metadata. What we can learn? We can learn the topology of the network. Yes, listening. What is happening? And if there is a part of the network we cannot access, we request for access. So passively, we can listen to what's happening on the other part. We learn about the amount of devices connected. This is very tricky. Typical question of the first day. Hospital director, hospital IT guy, how many devices do you think you have? Typical answer, 850. No, you have 923. No, yes, and I can give you a full list. And I give you a full list. So, this should be disconnected. This shouldn't be here. What's happening? This is not. Ah, it's true. I didn't remember that one. Yeah. Typical. We have the accurate amount of devices and actually the segmentation of the devices. We know which kind of devices, in which part of the network, and how much is producing, how much is working. we can determine the operating system and the operational functions of every single device, listening to the metadata of the data they produce or they exchange with our AI system. But not only that, additionally, we advise on things. For instance, the operating system of this is outdated. You should update it. This is important for the hospital director. You have 3 computerized tomography machines. They are completely overused. You should buy a new one. Or the other way around. You have 3 X-ray machines and they are completely underused. So you can access new ones, or you can even sell one because you are not using it. You can do the operation only in the 2 ones that you have left. And this is not so much technical advice, it's business advice. You can really revise your network. If it's under-dimensioned or over-dimensioned, if the list of devices has to be revised, to add, to remove, and to tune properly the network to the needs of your hospital. Or even allow more patients if your network allows to have more patients, and get a higher income, especially if you're a private one. Is there any security threat? That is an extremely tricky point. We are listening. We are listening to the metadata. There are some risks in security that we directly determine just by listening. Devices 1, 2, 3 are infected. And we can tell you now. There are 7 more that are possibly infected. We have not the certainty, but it's a good candidate to be infected because of the behavior they have. And of course, there might be others that we cannot perceive now that might be infected. But definitely, we can determine many things in the security thanks to the passive device we are inserting in the network. What are the kind of threats we are finding in the network? First of all, who is acting in the network? You don't have only the doctors that you have connecting to the network. There are 3 more people accessing the network. They should not be, and they are. Who are they? This one is a doctor we fired 6 months ago, and is still connecting from home with his laptop. Why is he entering? Good question. Now you know he is. Second, an unforeseeable access. The closed circuit camera. In an analysis we made of 8 closed circuit cameras, these cameras you put in your garden to watch that nothing's happening in the garden. 7 out of the 8 had hard-coded IP addresses. It means, for some reason, and you don't know it, the wonderful filming of your garden is being sent to an IP address, maybe in another continent. So you can see your garden and somebody else is also looking at your garden, or your hospital gate, or your hospital room. So if that is happening, we can stop that. I mean, not the passive device, passive is passive, but we can say data are coming out from this camera to another IP address. Is there any hack device? That is something I already mentioned. Is there any silent threat? What is a silent threat? A silent threat is you have plenty of medical data. If nobody changes that, if nobody modifies your operation, you don't feel there is any hack thing. But somebody's copying your data. Somebody's removing your data. Not, you still keep it, so you don't perceive anything. But he has a copy of your data. And that is stopped by a DLP, by data loss prevention, which is a procedure plus accompanied with software and changing the governance. And in the network, you can see there are data packages going out unnecessarily. So we can perceive this is happening. Is there any watering hole? Watering hole is a very, very interesting concept. A watering hole is in the savannah, this place with water where the tigers go to drink, and also the zebras go to drink, and also the gazelles go to drink, so everybody goes to drink there. While drinking, nobody attacks anyone, but in the watering hole, everybody gathers. If you're in a hospital and your hospital is well protected, nobody will attack it. But for some reason, most employees of the hospital connect every morning to the CNN newspaper website, the watering hole, or to the most important Serbian newspaper, the most important Polish newspaper, I don't know. And the website of the newspaper is weak. So The ones that want to have a watering hole to attack the hospital, they put the virus in the newspaper website. And as soon as you from the hospital connect, the virus said, oh, what is your IP address? Your IP address is the hospital. Okay, then as soon as you bring the newspaper page, you also bring something else with you, which is a piece of our software, a piece of our virus. And that's a way of entering the hospital. That's a watering hole. We can detect that. We can see, okay, what is coming from the network, from outside to the network, that's things which are not only pieces of information. Software's coming. We can identify that is happening. We can also identify netbots. Okay, what is that? Well, first of all, what is a DDoS? A DOS, only one D, DOS is a denial of service. So if you're a bank and you're an internet bank, you're accessing your current account through the internet, and the website of the bank is prepared to attend 50 customers in parallel, 100 customers in parallel, that's it. However, an attacker to the bank sets 100,000 customers entering at the same time. Once and again, every second. And that stops the bank. That's a denial of service. If you do that in parallel in several servers of the bank, actually in a distributed line of them, that's a DDoS, a distributed denial of service. Typical attack to a bank. I was a witness of one, actually. I was meeting one of our customers, a bank, and they had a DDoS in Peru. They stopped all the websites in Peru, and they say, we want a ransom, or we will keep sending millions of messages, and you cannot serve. We had a software. We stopped the DDoS, fortunately. We made a, let's say, a fancy page to deter the attacks, and the bank continued working. How can a hacker do that? Thanks to a hospital. That is where the hospital comes in. The camera, but the camera is just a camera. It can also be a pulsometer. It can be any device. Let's take the camera, for instance, for takes of ease. The camera is just a camera. You install the camera, and nobody reads the manual. The manual is just used to make the table more stable. Nobody reads it, right? And in the manual, they say, there is a code that by default is 0000. You have to change it the first day you install the camera. If you don't, somebody from outside connects the network, somebody from outside connects the camera or the pulsometer, and says, you are going to obey me. No, sir. No, sir. I only obey to my master who has a password. Is your password 0000? Yes, master. What can I do for you? Okay, dear camera, next Tuesday at 1 p.m., you're going to enter once every half second to that bank, again and again and again and again. That is a netbot. So your device in the hospital can become a netbot. And you say, okay, that is stupid that I take care of that. I am a hospital. I don't care about the banks. Well, you should, because when this is over, the bank says, who is attacking me? That was that device in the hospital. And the hospital gets a lawsuit from the bank because a device of the bank has been attacking. A device of the hospital has been attacking the bank. So it's better you analyze and avoid that any of the devices of the hospital becomes a network. How protected is the backup procedure? If it's not in cloud, and that is exactly Hospital Clinic Barcelona 2 months ago, if it's in a local place, a hacker may come and destroy the current system and the backup. And the hospital had to cancel 3,000 operations and 5 days out of system. 5 days out of system, because the backup was not properly protected. So protecting the backup, putting it in a cloud, or having the right protection is definitely important for your hospital operation. So, basically, we listen and we act, and what we do is providing not only network advisory, but we also provide managed security services. And what we do is do it 24 hours a day, 7 days a week, 366 days a year, worldwide. We have 16 security operation centers in all continents, which are continuously updating about the threats which existed. Every day there are new threats. New one in Malaysia. We learn about it in 1 day. So if somebody attacks your Italian hospital, we will know, we will help you. So Next time that it's a Saturday, 2 a.m., and somebody wakes you up and you have to go to the hospital to heal it, don't worry. Don't worry. Our security guys will go. Our security guys will see what the problem is, will sort it, and you can perfectly go back to bed. Thank you very much. Questions?
Can you hear me now? Yeah, great. Thank you for your presentation. I'm just interested in your passive device that you're installing at specific location. How well protected is from electromagnetic radiation?
Good point. We have selected actually 5 different devices. They are not ours, they are from different producers, from different manufacturers. You can choose any of the 5, which are perfectly, what's the word? Certified, perfectly certified, perfectly connected. Our point is the software. So you take any device, you take a Dell device, you take anyone, you put the device, put our software there, and our software connects to our cloud, where the artificial intelligence software is running, actually, because the passive device is just an ear. It's a big ear that you put in the network, and everything else is processed on our back. And obviously, our backup system is certified. I mean, our connection is secure. All data, all metadata are protected. And then what we do is to process what we listen.
Thank you.
How long does it take for a hospital to migrate services?
Well, okay. Maybe the word migrate is, I don't know if it's applicable here. Putting a device on a passive way and giving you a first snapshot of what's happening can be 2 weeks. Because it's not migrating, you're changing nothing. We are just putting an ear in the middle of your network. And then we listen. And in 2 weeks, we can tell you, this is your topology, this is the amount of devices, this is what's happening, and this is the threats which are identified. You can also say, okay, let's act more. I mean, let's go to the suspicious one and then act, but then it's not only device, it's entering it's not passive. I mean, it's entering the device, seeing what's happening, installing the antivirus, that's managed service. But the advisory, 2 weeks.
Oh, for the managed services, I thought.
For the managed services, that depends on what you want to manage.
Yeah.
I mean, maybe 1 month, 2 months, we can set a full operational model. Depends on the size of the hospital as well. But it depends on how you work. It depends how big you are and the expectation you have from the managed service. Because there are several scopes of services. Security is one, operation is one, backup is one. Backup is quicker because backup is business as usual, but other ones demand other things. 2 months maximum.
Josema, thank you very much for this amazing talk. Here is your certificate of appreciation for your engagement in DSC Europe 23. Thank you so much.
Thank you very much.